Wow, I'm glad to be here again, my dear students. Today, we want to round up the topic we started some few days ago, which is mensuration. And today, we're going to conclude with the subtopic area of segment. At the end of the lesson today, it is expected that all students should be able to recall and use formulas to calculate area of segment. Number two, it is also expected that all our students should be able to solve other problems involving segment. Now, area of segments. Area of segments. Now, let us consider the diagram below. In this diagram, we have a circle with a triangle inclusive. Now, we have the shaded part. The shaded part is called the segment. Don't forget, I've told you a segment can either be a major segment or minor segment. It does not matter. What is more important is when you are asked to calculate the area of segment, either minor or major, just have it at the back of your mind that the area of a segment is equal to area of a sector minus area of triangle AOB. Now, the area of sector is theta over 360 times pi r square minus area of triangle AOB, which is half r square sine theta. So now, I'm very sure and I want to believe that this is not going to be a problem since we have dealt with area of a sector before. Just have it at the back of your mind that area of a segment is equals to theta over 360 times pi r square minus half r square sine theta. Now, let's look at the example 1. Calculate the area of the shaded segment of a chord shown in the diagram below, taking pi to be 22/7. Now, this is the diagram. The diagram we are having here is a combination of a sector and a triangle. If you cut off the shaded part, you'll be left with a triangle. And then if you add the shaded part to it, then what you are going to have is a real or a complete sector. So invariably, what we are going to do here is to find the area of a segment. Now, theta is given to be 63 degree, while our r is given to be 7 centimeter, and pi is 22/7. Don't forget that anytime you want to find the area of the shaded segment, you need to write out the formula, which is theta over 360 times pi r square minus half r square sine theta. Now, when you now substitute, you have 63 degree over 360 degree times 22/7 times 7 square minus half times 7 square times sine 63. So by the time you substitute, you have, at the end of the day, you are going to have 22 times 49/42 minus 49 times 0.8910. Now that 0.8910 is the value of sine 60 degree over 2. Now finally, you have 26.95 minus 21.82, which will invariably give us 5.13 centimeters square. So that is the area of the shaded segment. Now let's look at example 2. What is the area of the shaded region in the diagram below, taking pi to be 22/7? So this is the diagram. Just like the first example, here our radius is 7/1/3 centimeter, while the angle is 93 degree. So like I said, we need to write out the parameter. Theta is 93 degree, r is 7/1/3, while our pi is 22/7. Now, area of the shaded region. is equals to theta over 360 times pi r square minus half r square sine theta. But lest I forget, now our radius is given to us as 7/1/3. Now when you change it to an improper fraction, it becomes 22/3, which is 3 times 7 plus 1/3. And so that is how we got 22/3. So invariably, wherever you see r, our r will now become 22/3. So we substitute 93 degree over 360 times 22/7 times 22/3 times 22/3, then minus 1/2 times 22/3 times 22/3 times sine 93 degree. So when you solve that, you are going to have what we have here: 990,264 over 22680 minus 484 times 0.9986 over 18. Finally, you have 43.66 minus 26.85, which invariably will give us 16.81 centimeter square. So this is the classwork I'm giving you. The diagram below shows the shaded segment of a circle of radius 7 centimeter. If the area of the triangle OXY is 12 number 1/4 centimeter square, calculate the area of the segment. Pi is given as 22/7. So this is the classwork. Look at it very well. This is the classwork, and the assignment I'm giving you is find the area of the shaded region in the diagram below when the area of the diagram is given as 3/1/6 centimeter square. This is the diagram that you are going to use to find the area of the shaded portion. I believe that you have been able to gain quite a number of things starting from the beginning up to now. Please, if you still have any challenge or any issue, don't hesitate to send me a mail or to comment, and your comments will be treated accordingly. Once again, I still remain your mathematics teacher. Thank you for listening, and God bless.